So now we're ready to evaluate some expressions, trig expressions. Okay, so all right, so let's take something such as the sine of 30 degrees minus 5 times the cosine of 45 degrees. So you notice that you're using two special right triangles. So I'm going to draw a line here so that we can actually show our work on this side. The first thing you probably want to do is draw the two right triangles so that you can get their side lengths. So I'm going to draw my right triangle. Okay, this is your 30, 60, 90 triangle. Remember that across from 30 is 1, a length of 1. Across from 60 is the root 3 length, and the hypotenuse is 2. The other right triangle that you're going to refer to is the 45, 45, 90. And if you remember, those lengths of the sides are 1, 1, and the square root of 2. So what we need to do now is we need to evaluate sine of 30 degrees. Well, sine of 30 degrees is in quadrant 1. Okay, I'm going to sweep that radius until I hit about 30 degrees, which is in quadrant 1. So now that I have my triangle, then I can use what I know about the 30, 60, 90 triangle. So again, I have a value of 1 here, opposite of 30, or theta. Square root of 3 is adjacent, and 2. Sine is opposite over hypotenuse, or you can also write y over r. That's going to be a value, a ratio of 1/2. Remember that a sine of theta is going to produce a ratio. So the ratio for this is 1/2, opposite over hypotenuse. Minus 5 times, now we got to evaluate cosine of 45, which is also in quadrant 1. Okay. And so this is 1, this is 1, and this is a square root of 2. Both are in quadrant 1, which means x and y are both positive. So the ratio for cosine 45, which is adjacent over hypotenuse, or x over y, x over r, is going to be 1 over the square root of root 2. Okay. So what we're going to do is go ahead and start simplifying this expression. So we have 1/2 minus 5, because 5 times 1 is 5, over root 2. And it looks like I have two different denominators. So what I'm going to ask you to do first is rationalize the denominator. So we're going to multiply by a form of 1, root 2 over root 2. And so what that allows me to do is rewrite this value right here, this fraction. That's going to give me 5 root 2 over 2. And now, if you look, you have a common denominator. So you can either leave it like this, or you can combine both fractions as 1. They both have a denominator of 2, which would make the numerator 1 minus 5 root 2. And this would be your final answer. Okay. Okay, let's go ahead and do another example. All right, the example, let's see. So the next example is going to look like this. We're going to, again, evaluate the expression. One thing I didn't note in the problem before is you have to leave it as an exact answer, okay? So this time we're going to evaluate sine of 30 degrees minus, oh, we just did that one. Okay, so let me rewrite that. All right, second one is this secant of pi over 6. So now we're working in radians, and we're going to square that whole expression times the cotangent of pi over 4. Okay, so I'm going to draw a line so you can do your work over here on this side. What you want to do is make sure that you draw your triangles first. So we're going to work with pi over 6. Because you've been converting, I think there were some that I pointed out to you that you have to know. One of those things is that pi over 6 is equivalent to 30 degrees. If you don't know that by memory, then you need to do the conversion so you can tell which quadrant it will be in. So I'm going to sweep that radius. It's going to be in quadrant 1. So this is 30 degrees. I'm going to drop the perpendicular. So I'm going to put my theta, which is 30, and I'm going to label the sides 1, square root of 3, and 2. The next one I'm going to draw is pi over 4. And again, you guys should know that pi over 4 is equal to 45 degrees. If you didn't know that, you could do the actual conversion, just to give you an idea of what quadrant you're in. So I'm going to sweep the radius, and we're going to be about the middle of quadrant 1. Okay, theta is 45 degrees. We're going to drop that perpendicular line. This should be a value of 1, 1, and then square root of 2. So I have the two triangles that I need. So now we have to evaluate first the secant of pi over 6. You have to first remember that secant is the reciprocal of cosine. So we're looking at hypotenuse over adjacent, or that the equivalent would be r over x. So using pi over 6, and actually I shouldn't have allowed us to write this in degrees because they gave us radians, and I just realized that. So we should have put pi over 6. Even though it's equivalent in degrees, they gave us radians, we got to stay in radians. And this should be pi over 4. I just wanted you to realize it was 30 and 45 to know where to place the triangle. Okay. All right. So pi over 6, secant pi over 6. I'm looking for the radius, which is 2. So the ratio for secant of pi over 6 is 2 over the square root of 3. You don't have to rationalize it yet because you're still working the problem, and you don't have to rationalize until it's absolutely necessary. Remember that you're squaring this, okay, times the cotangent of pi over 4. So you have to remember that the cotangent is the reciprocal of tangent. So what we're going to have is adjacent over opposite, or x over y. Okay, so go to the triangle that deals with pi over 4. Our x value is 1, our y value is 1. So we have, for the ratio, cotangent pi over 4 gives us the ratio 1 over 1, or 1. Let's go ahead and simplify this. So we have to square the entire fraction. 2 squared would give me 4, but root 3 squared would actually give us 3, times 1, which is equal to 4/3. And that's what your answer will be for this expression. Okay. So some other types of problems that you're going to see are going to deal with the unit circle. So we're going to want to evaluate more expressions, but we have to review the unit circle. In order for us to, the quadrantals. In order for us to do that, we do have to talk about the unit circle to make sure you know what it is. So I've already told you that I'm not going to have you memorize the unit circle. We show you how to use the two special right triangles, so you can draw a triangle anywhere in a circle. The radius is whatever number it is. It doesn't have to be 1. In a unit circle, that's going to be a case where the radius is equal to 1 every time. Okay. So I'm going to draw a circle, and I'm going to go ahead and put my y and my x-axis down. So for a unit circle, no matter what radius you have, when it touches the edge of the circle, if that length is 1, then you're dealing with a unit circle. So there's 4 points, quadrantals, that I had you guys recognize the other day. So this is 0, right? It's a quadrantal because it lies on the x-axis, okay? This is another quadrantal point, and that's going to be pi over 2, or 90 degrees, okay? Because, again, it lies on an axis, the y-axis. As I continue going around, this is also a quadrantal, and that's going to be for pi, or 180 degrees. The next quadrantal is going to be 270 degrees, or 3 pi over 2. And then once we make once we make it around the circle, you remember that you've reached 360, or 2 pi. So all of these are quadrantals because they lie on the circle. Okay, they lie on the axes of the circle. So what we have to do now is this. We got to actually realize that when I'm dealing with a radius, that can go from the center to any point on the circle, including the center, from the center to, let's say, this point, this quadrantal. That distance is going to be a radius as well. But because the radius is 1, then we're going to go ahead and write that. The reason why that's important is because now I can identify the coordinates of that quadrantal. At that quadrantal, x is 1, but y is 0. Okay, so when I'm listing these out, I want you to think about the x, the y, and the r's that we talked about the other day. My radius is 1 no matter what for a unit circle. For the quadrantal, my x is 1 and my y is 0. So for each quadrantal, I want you to list the x, the y, and the r, and then the coordinate point as well. Okay, let's look at this quadrantal. So from the origin up, again, I have a radius of 1. So that would make the coordinate points for this one 0 for the x and 1 for the y. So when I list my x, y, and r, I have 0, y is 1, and the radius, of course, is going to be 1 for the unit circle. Okay? Okay, let's go to the next one. So let's go to this quadrantal. So again, this is going to be a distance of 1. So the coordinate points for this are going to be -1 because you're to the left of the origin, and 0. So I have x is equal to -1, y is equal to 0, and of course, r is equal to 1. Okay, next quadrantal, 270. The radius, of course, is 1. Okay, so our coordinate points are going to be 0 for x and -1 for y. My x, y, and r value, r is going to be 1, y is -1, and x is 0. And so now we have all of the coordinates for the quadrantals. The reason why this is important is going to keep showing up, but it's important because we're about to evaluate some expressions that deal with quadrantals. So let's go ahead and look at those. Okay. So let's say that I give you something such as this. So our job is to evaluate and to give an exact value. So if I give you something like the sine of 180 degrees to evaluate, you'll have to recognize that theta is going to go from here to the other side of the y-axis. So 180 degrees, remember, is a quadrantal. So I know that x is equal to -1, y is equal to 0, and r, the radius, is equal to 1. I also know that the ratio for sine of 180 is opposite over hypotenuse, or you can use y over r, which is going to give us a ratio of, so if you look at the list, x, y, and r, I have a y value of 0 and a radius of 1, and 0 divided by 1 is actually 0. So then the sine of 180 degrees is equal to 0. Okay? So let's try a couple more just to make sure that we have it. Now let's look at the cosecant. The cosecant of pi. All right, one more time. This is just testing whether or not you recognize the difference between the degrees and radians. So from 0 to the negative y-axis, portion of the y-axis, that's pi. So it's equivalent to 180. So one more time, x is equal to -1, y is equal to 0, radius is equal to 1. The ratio for cosecant is equal to, remember, it's the reciprocal of sine, so it's hypotenuse over opposite, or r over y. Well, the radius is 1 and y is 0, so you have to be careful with this. If you have a 0 in the denominator, that's undefined, and that's exactly what you would write. So undefined is going to be the answer for this. Okay? All right, last example. So let's say that we give you something a little bit larger in terms of an expression. So we'll do it in this portion here. So we're going to evaluate 7 times the cosine of 3 pi plus 3 cosecant 3 pi over 2. So like with everything else, we have to know where those angle measures are going to lie. So I'm going to start on the positive x-axis like we do with everything, okay? And I'm going to start rotating because 3 pi is positive. So I'm going to rotate counterclockwise, and I've hit 1 pi. And then I'm going to go around again. This is 2 pi. And then to get to 3 pi, I'm going to have to go around again. So it's larger than one rotation, but 3 pi hits the same spot as 180 degrees or pi. Cosine, remember, is adjacent over hypotenuse or x over r. So we're going to have 7 times the ratio for cosine of 3 pi. If I were you, I would list that x, y, and r value. I know we've already done it. Okay, so cosine is x over r. X is -1 over the radius, which is 1. And let's go ahead and evaluate the next one. So we need to find 3 pi over 2. So look at the denominator. It is halves. And so what we need to do is make sure that the top half is divided into 2, which it is. Here's 1, 2, and then the bottom as well. So if this is 0, I'm going to move counterclockwise. This would be 1 pi over 2. This would be 2 pi over 2. And then 3 pi over 2, just in case you guys forgot, is going to be another quadrantal. So we have 3 pi over 2, which, by the way, is equivalent to 270 degrees, right? Okay, so my x value is 0, my y value is -1, and my radius is 1, okay? So for cosecant, that's the reciprocal of sine, so that's going to be hypotenuse over opposite, or r over y. So my r value is 1, so 3 times, and then the ratio of this cosecant 3 pi over 2 is 1 over, and then your y value is -1. So we're going to simplify now. So 7 times -1 is -7, plus 3 times -1 is -3, which gives me a value of -10, and that's your final answer. Okay.